Hi, I'm George Woodbury from College of the Sequoias, and in this video we're going to take a look at working with a function that's exponential that was given to us to work with. So rather than coming up with the model's already given to us. The average annual income of a person with an advanced degree can be approximated by f of t equals 18,000 times e raised to the 0.04 t power, where t represents the number of years after 1975. Use the function to predict the average annual income of a person with an advanced degree in 2030. So we have this function, f of t equals 18,000 times e to the 0.04 t power. And f of t, that represents the income, and t represents the time in years. Working with this type of problem, you're going to be given one of two of those values. You're either going to be told the time and find the income, or you're going to be given the income and find the time. In this problem, it says use the function to predict when the average annual income of a person with an advanced degree in 2030. So we're given the time. 2030, by the way, since this is the years after 1975, 2030 minus 1975 is 55, and that's our value of t. So we're just going to evaluate this function for t equals 55. F of 55 equals 18,000 e to the 0.04 times 55. Now, if you're not good with your calculator yet, you may want to do 0.04 times 55 first and come up with a single number there, but we can do this all in one shot in the calculator. Let's take a look at that. 18,000 times function e to the x, back to main, in parentheses, 0.04 times 55. And on the right, we weren't told where to round here, so we want to think about where does it make sense to round to. And there's two choices that we have. We can round to the nearest dollar, which is the way it was given. That 18,000 is to a nearest dollar as well. Or we could do it in dollars and cents with two places after the decimal point. I'm going to just round this to the nearest dollar, $162,450. Get an advanced degree before 2030. All right, let's take a look at the other one where we're going to be working the other direction. I'm going to give you an income, and we're going to figure out when that's going to occur. Also remember that t is the number of years after 1975. So this time we want to know when it will reach $200,000. So this is what f of t equals, and we're trying to find what t is. So copy down the model. F of t equals 18,000 e to the 0.04 t. The $200,000 is going to go in on the left-hand side. 200,000 equals 18,000 e to the 0.04 t. Now we need to solve for t. That means we need to start by isolating the exponential part. Divide both sides by 18,000. Okay, that doesn't divide evenly, and we can work with the fractions, but it sure would be nice to type less numbers in there. And so we know if we divide both that numerator and denominator by 1,000, the last three zeros are going to disappear. And so we end up with a fraction that's a little easier to work with, 200 over 18, easier to type. We could keep reducing it to get 100 over 9 if we wanted to, but that's good enough for now. Equals e to the 0.04 t. Let's take the natural log of both sides. And just like in the other problems, the right side, we're left with just the exponent, 0.04 t. We finish by dividing both sides by 0.04. And we can go to the calculator here. We're looking to estimate the year that it happened, so we're going to round to the nearest year. function, natural logarithm. Inside the parentheses, we go back to main, 200 divided by 18. Tab outside those parentheses, divided by 4. No, not 4. Divided by 0.04. There we go. We get 60.19. That's going to round to 60 years. So T is approximately 60 years. And if we add that to 1975, that's going to occur in 2035. 1975 plus 60. All right. That's the end of this video for working with a given exponential model. We'll tackle another problem in the next video.